Today we're going to be doing a video on natural sciences using the derivative. Here we have a cone, alright? And this is going to be normally a word problem, and you have to extract the data from that word problem to use to find the height or the volume or whatever it is it's asking you. Here, if you look up here, it is asking you, if I am adding water so the surface of the water is increasing at a constant 1 inch squared per minute, then how fast is the height of the water changing when it is 4 inches deep? So I've already boxed it up. I've already looked at it. We're going to go ahead and call your 1 inches squared min dA dt. That's going to be your area. And then your height is just going to be dH dt. And then your 4 inches deep is going to go ahead and be your h. Now, whenever you're doing a cone, the volume is automatically going to be 1/3 times pi r squared times h. That's a common rule. And one easy way to go ahead and make you think about this is to think similar triangles. Here, I've already showed you that 4 inches deep. I'm going to go ahead and put that as the top and 6 inches as the side. Go ahead and think of it that way. And that's already been given to you. It's already been given to you that that is 6 inches. So we're going to have h over r, height over radius. And your radius is just half of this. So it's only going to be 2. It's not going to be 4, it's going to be 2. H over r is now going to be 6 over 2, which now h, your height, is now 3r. Or your r is now 1/3 h. And you know from over here that 1/3 times 4, you're going to get 4 over 3. You got the 4 from it being your radius, or being your height, I apologize. See right here? What it is, h is going to be your height, 4 inches deep. You take that and plug that into your equation here. So you take that, plug that in for your h right here, and now your r is now going to equal 4/3. Okay, so now you know what r is, and you can go ahead and plug that in to h to find out what h really is. But right now we're going to go ahead and figure out what is a, the area, dA dt. You know what r is, so you plug in r and square it after you take the prime, because remember, you're doing dA dt, which means you're taking the prime of what's on both sides. That's just going to be 1 equals to 2 pi times 4/3 r prime. And you want r prime to be by itself, so you go ahead and divide that into there. And now r prime is equal to 1 divided by 2 pi times 4/3. Now you have your r prime. So you have your h, you have your r, you have your r prime. Now the question is, what is h prime? That is what this whole question is asking you, is what is h prime? What is your height of the water? What is the height of the water changing when it is that deep? So in order to find h prime, you have 3 times r prime. Because remember again, follow my arrow right here, take the prime of all that, you have 3 times what you had found r prime to be. After you multiply those through, you'll find that h prime is 9 over 8 prime inches per minute. And that is the answer to your question. Okay guys, I realized I made a mistake. When I told you h prime, that's pi. That's 9 divided by 8 pi, not 8 prime. No. That's h prime is equal to 9 divided by 8 pi inches divided by, or inches per minute. This is your final answer. The question was, how fast is the height of the water changing when it is 4 inches deep? That is the answer.